guys, welcome back. This is Sandesh from Acha Physics. In the last video we have seen a free body diagram, what is it and all. So in this video we will try to understand the applications of the free body diagram. I mean how to solve the different mechanical problems by using free body diagram. So in this video I will be taking 3 examples, out of which I am taking the first one is here. So where I have one surface which is very smooth, I mean this is frictionless, and on which there are 2 blocks are placed of masses m1 and m2. These 2 blocks are in contact with each other on the surface. Now on this system let me apply a force F, and with this force the entire system, assume that it is accelerating with a magnitude is equal to A in the direction of the applied force itself. And one more important thing that we have to observe here is when the system is accelerating with this much of magnitude, these 2 blocks are not getting separated. But one important thing is m1, when it is pushed by this force F, this m1 is going to apply a force on m2. Similarly, m2 is also applied a force on m1, because it is reasonable to consider this, because even when they are moving with this much of acceleration, they are not getting separated. When there is no relative displacement between these 2 blocks, even when they are moving, we have to consider there is a equal and opposite forces between this m1 and m2. So assume that the force applied by m1 on m2 in this direction, so that is equal to n. The same force is applied by m2 on m1 in the opposite direction, so that is over n. Now to find out this applied force F on this system, I will be using a free body diagram of m1 and m2, and from that we can easily get what is that F. So let me write the free body diagram for the block m1, neglecting everything in the surrounding of m1, but m1 alone is considered. On this block, along the x-axis, there are 2 forces are acting that we can see in this diagram. One is the applied force along the positive x-axis, and the other is this normal reaction N applied by m2 on m1. So those 2 forces can be represent something like this. So here I am not considering the forces along the y-axis, because the object is not accelerating along the y-axis. So here, as a result of these 2 forces, the m1 is accelerating with the acceleration is equal to A. So now if I write the dynamic equation for the first case, I will be getting like F minus N is equal to m1 into A. So this, let me call this as equation number 1. Similarly, for m2, if I write the free body diagram, so you can see that there is only one force is acting on m2, because there is no friction, because the surface is smooth. That one force is this normal reaction provided by m1 on m2. So that normal reaction is this, and this is a block of mass m2, and it is also getting accelerated with the same magnitude equal to A. So therefore the dynamic equation for this block is N is equal to m2 into A. So this is nothing but the Newton's second law of motion, because any resultant force can be represented as the magnitude of mass of that object into its acceleration. So from this equation number 1 and 2, what I can write is, I substitute this N over here in the first equation. This will be F minus, in place of N I substitute it is m2 into A, that will be equal to m1 into A. So I will take this to the RHS, so that equation will be m1 plus m2 into. So this is what the required equation which is obtained by using this free body. As a second example, I will be taking the same 2 blocks m1 and m2, but they are not in contact with each other. They are getting separated with a certain distance, and they are connected with a massless and inextensible string. And as usual, it is placed on the smooth frictionless surface. If suppose this system is pulled in this direction with a force is equal to F. So what happened is the string is not going to extend, or and I told you it is massless. The entire system is going to accelerate it in the same direction. Let me call that acceleration is A. So we have to calculate what is this applied force in this case by using the same free body diagram. But before going to the free body diagram, you have to understand that there is a tension in the string. So there is a tension in the two directions. One is because this block M1 with this force, when it starts moving in the direction of the force, it is going to pull this M1 through this string. So therefore it is applying a tension over here. Okay, so this is what the tension applied by M2 on M1. Similarly, because the distance between these two blocks is not getting changed even when the system is accelerating with the acceleration A, that means the block M1 is exerting the same tension through the string on M2. Okay, because I told you the same reason, they are not getting separated even when they are moving. When the relative displacement is 0, we have to consider the forces are equal and opposite, so that the net force is 0. So that the block M1 is also exerting a tension on this M2, and that is in this direction. So that equal and opposite tension, let me call the tension is T over here. So now let me write the free body diagram for this M1 and M2 next. As usually, you know that. So I'll write M1 alone by neglecting every surrounding. The only force acting on the M1 is in this direction, that too it is equal to T. So therefore tension in this direction, and the block M1 is accelerating over here with the magnitude is equal to A. So therefore the dynamic equation for this block M1 is T is equal to M1 into A. Let me call this as equation number 1. Similarly, on this block M2, there are two forces you can see. One is this external force F, which we have pulled, and the second thing is the tension acted upon by M1 on M2, that is in this direction. Okay, so if this is block of mass M2, tension is in the opposite direction, and this external force is there in the forward or the positive x-axis. So that the dynamic equations for this system will be, so F minus T is equal to M2 into A. So because even this block is also accelerating in the same direction with the same magnitude, therefore it is M2 into A. Let me call this as equation number 2. So finally we have from the equation 1, T is equal to M1 into A. Therefore this equation number 2 will be F minus, in place of T I'll substitute this, it is M1 into A is equal to M2 into A, or finally this F is equal to M2 or plus M1, whole thing is multiplied by A. So this is what the required equation, which is easily obtained by using this free body. One thing we have to see in this example is, in the previous example, the role played by the normal reaction between the blocks which were in contact is now played by the tension. So therefore normal reaction in the previous example is exactly same as the tension in the present. As a last example, we have another mechanical systems of two blocks M1 and M2. So they are connected by massless and inextensible strings over here in between them, and the system is pulled against the force of gravity with the force equal to F. And because of this, the acceleration of the system is A, that too in the upward direction. So when the system is accelerating in the upward direction, there is no relative displacement between the two blocks, which means as usually when you pull this block M1 with a force F, this M1 is going to pull this M2 through the string. So that means M1 is exerting force on M2, but still since there is no relative displacement between the two blocks, we have to consider that m2 is also exerting force on this m1. That equal and opposite force, here also it is nothing but the tension along the string. The tension is there in both the sides between the blocks. Well, so to calculate this applied force F, which is applied against the force of gravity, once again we will be using the free body diagram for the block M1 and then for M2. So free body diagram for M1 is as shown in the figure. So here I have to write the forces along the y-axis because there is no acceleration of the system along the x-axis. The one force is in the upward direction, that is applied. Let me call that as F. The another force acting on M1 is this tension, okay, tension provided by this M2, which is in this direction. So this is what the tension, and you need to understand this tension acting on something is always away from the object. So here in this diagram, tension in the string acting on M1 is away from M1. Similarly, tension in the string acting on M2 is always away from the M2 in the upward direction. So therefore, on M1 the tension in the string is in the downward direction, but not only the tension alone in the downward direction, M1 into G, I mean the weight of the object, is also acting in the downward direction. So as a result of all these forces, this M1 is getting accelerated in this direction. The magnitude is equal to A. So the dynamic equations along the y-axis can be written as F minus T minus M1 into G. So these two forces are negative because they are in the downward direction, and F1 is positive because in the upward direction. So as a result of this force, the total force acting on M1 is M1 into A. Let me call this as equation number 1. Similarly, if I write the free body diagram of M2, so here is a block of mass M2, and you can see that the total force acting on M2 are only two along the y-axis. One is tension in the string on this M2, it is away from M2. Let me call the tension is T. Similarly, the weight of M2 itself, the weight is M2 into G. So as a result of these two forces on M2, it is accelerating in the upward direction with the same acceleration A. So therefore, the dynamic equation for M2 can be written as T minus M2 into G is equal to M2 into A. Let me call this as equation number 2. So now, if you take this M2G to the RHS, you will get T, and substitute that T over here, so that we will be getting F as we have done in the last two cases. So I hope you understand how to apply or how to use this free body diagram in solving different mechanical problems. Similarly, the same method of free body diagram can be applied anywhere. Okay, like a block of mass M is sliding along or sliding down the inclined plane, and different pulley cases and all. So I hope you understand. I hope you understood what is free body diagram and how to use the free body diagram in solving different mechanical problems. So thank you for watching.